Welcome to Tuesday, December 9th, 2025 severe weather analysis for Brisbane. This morning's sounding was taken at 10 a.m. local time, and we are seeing some interesting atmospheric dynamics at play. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we have 0 joules per kilogram of mixed layer CAPE, which tells us the boundary layer is essentially stable. However, the most unstable parcel shows 584 joules per kilogram of energy, indicating there's instability aloft if we can tap into it. The lifting condensation level sits at 940 meters above ground, which is favorable for storm organization if convection develops. Wind shear through the lowest 6 kilometers measures 18 meters per second, which is excellent for organizing any storms that do form. The supercell composite parameter of 0.74 and significant tornado parameter of 0.22 suggest organized multicells with rotation are possible if storms can break through. The keyword here is if. Now let's look at the afternoon transformation. As temperatures climb to a forecast maximum of 31 degrees Celsius, we are heating the surface parcel while keeping its moisture content constant. On the heated skew-t, you can see the pink shaded area showing CAPE expand dramatically. The most unstable CAPE more than doubles to 1387 joules per kilogram. The blue shaded area showing convective inhibition remains minimal, meaning there's essentially no CAP holding storms down. The heated parcel path, shown in orange, rises freely through the atmosphere once it reaches its level of free convection near 800 hectopascals. Wind shear remains strong at 18 meters per second, and now we are generating meaningful helicity with storm relative helicity values of 99 meters squared per second squared in the lowest kilometer. The supercell composite parameter increases to 0.96, and the significant tornado parameter climbs to 0.43. This afternoon environment supports organized multicells or possibly supercells if storms initiate. Looking ahead to tomorrow morning, the machine learning forecast shows a dramatic change. CAPE drops to 0 joules per kilogram, with surface-based CAPE also at 0. Wind shear decreases to about 6 meters per second. The lifting condensation level rises to 1152 meters above ground. Both the supercell and significant tornado parameters drop to 0, indicating a subconvective environment. Tomorrow morning looks completely benign. By tomorrow afternoon, conditions remain subconvective. The forecast shows 0 joules per kilogram of CAPE and surface-based CAPE, with wind shear around 7 meters per second. The lapse rate between 700 and 500 hectopascals is 5.8 degrees Celsius per kilometer, which is marginally unstable but insufficient without low-level moisture. All severe weather parameters remain at 0. Tomorrow afternoon brings no thunderstorm threat. The hodograph reveals important details about storm motion and organization. Wind vectors curve through the lowest 12 kilometers, with a profile colored by height showing veering winds with altitude. This creates storm relative helicity, the spinning motion that can lead to rotation in updrafts. The bunker's right mover motion vector points to the east-northeast, so if supercells develop, they'll track toward the east-northeast. The 0 to 6 kilometer shear of 18 meters per second is well above the threshold for organized storms. The 0 to 1 kilometer shear is nearly 4 meters per second, providing low-level rotation potential. The 3 kilometer storm relative helicity of 280 meters squared per second squared is moderate, supporting mesocyclone development if storms form. The atmospheric refractivity profile shows stability characteristics through the vertical column. We can see elevated duct conditions between about 1200 and 1600 meters, indicated by the orange shading. This represents a layer where radar beams can propagate abnormally, which meteorologists call ducting. Below this, we have superrefraction zones shown in pale yellow between about 1000 and 1500 meters. These stability features don't directly impact convection but are signatures of the temperature and moisture structure. The relatively smooth refractivity curve through mid-levels indicates no strong stable layers that would suppress updrafts. In summary, this afternoon shows marginal severe weather potential if storms can initiate. We have the ingredients: 1300 joules per kilogram of most unstable CAPE and 18 meters per second of deep layer shear. But this is conditional severe weather. We need a trigger mechanism, whether it's sea breeze convergence, an upper-level disturbance, or orographic lift. Always consult the Bureau of Meteorology for official severe weather warnings and current radar imagery. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.